Combinations and permutations. Right, so you're looking at, this was a handout that I made last year, so for the 9 examples of our essential standards. So in here, combinatorics, combinations, permutations, is actually called 8. So why don't you open it up to that, and we will talk about these briefly. For combinations and permutations, we'll do a brief overview. We have combinations, so NCR. Why don't you raise your hand and describe to us how we calculate NCR?
Sorry, George, we're not
No, I mean without the calculator.
Oh, we don't actually do
We don't do that. Yes, you do. Hey.
It's n, the exclamation point.
What's that called?
X factorial.
Factorial. N factorial over.
Over n. Okay, I have this n minus 1 factorial.
N minus R factorial.
Oh,
And?
and it's the extra one. So and then another r factorial.
All right, it's the extra one, right? R factorial. So combinations are less than permutations. What's the difference between combinations and permutations?
Oh, one of them order
Right.
matters.
Okay, so for combinations, we're going to say order does not matter. And for permutations, NPR, n factorial over n minus r factorial, order does matter. Okay, so it's easy for me to say, it's difficult for you, being the student, when you read through a question, to determine, is this a combination or a permutation? Okay, so that's the difficult thing. My advice to you is to do as many questions as you can. Be there with your book, look through the odd numbers, look at the answers in the back, and skip around from sections, because when you're in a specific section in the book, they're all going to be combinations. And you turn a page, you go to a different section, they're all going to be permutations. So I recommend either going to the back of the chapter, or really skipping around and doing a variety of questions to get used to determining which is which. Okay, we also have circular permutations. Circular permutations, and we calculate that by,
It's n minus 1 factorial.
Good. N minus 1 factorial. We have permutations for identical objects. Permutations with identical objects. What's the example we did in class? Mississippi. All right. And so n factorial over r factorial, etc. Okay. And lastly, associated with the combinations and permutations, we have fundamental counting principle. Fundamental counting principle. And what was our example that we went through over and over and over?
The locker.
Locker combination, license plate. Yeah, license, how do we spell license plate? License plate example. Okay. So, overview of the information associated with combinations and permutations. Let's see if we can talk about these questions briefly. Question number 1. Pally has 12 members on the JV girls basketball team. Only 5 of the 12 may be on the court at any one time. How many different groups of 5 are there? Is that a combination, permutation, circular permutation? Maybe they're all around in a huddle. What is it?
Combinations.
That's combinations. All right, and the word group in here kind of gives that away. But anyway, there you have it. So this would be a combination example. And to determine that, to calculate it, it would be 12C5. 12C5. So I'll just write that briefly. So for question 1, 12 members on the Pally JV girls basketball, it would be 12C5. And so we would have 12 factorial over 7 factorial 5 factorial, and that's going to be some somewhat large number. I heard calculator buttons going. What'd you get?
I don't know how to do that here.
Uh-oh. All right, well, the common mistake, let me show you, this is fascinating. The common mistake that students make is they type in this, 12 factorial divided by 7 factorial times 5 factorial. And what the calculator tells them is wrong. Because your calculator divides and then gets an answer and then multiplies by this. No, no, no. You would have to do this, 12 factorial divided by, and then in parentheses, you could do 7 factorial times factorial. You could also type in 12 factorial divided by 7 factorial divided by 5 factorial, and your calculator will give you the correct answer. What did we get?
792.
792. Sounds okay to me. All right. Now, how could... All right, next question. Number 2, Mr. T has to select a class treasurer, president, and vice president. If there are 35 students in class, each of which is qualified for each position, how many possibilities are there?
Permutation.
That's a permutation, all right, because if you're president and Jonathan's vice president, that's different from he's president and you're vice president. See all those campaign posters outside? Okay. So this would be for question number 2, a 35P3. Which is going to end up being 35 times 34 times 33. Yeah, Amy.
So for the questions when you have to multiply the permutations together, like if they have 2 different control group kind of things?
Well, we did several where it was combinations from 2 groups.
Okay, so you always just like, you do the separate problems, but then you multiply them together.
Right, that's like fundamental counting principle. You have some number of possibilities for this, some number of possibilities for this, multiply the 2 together.
And when do you divide by the total?
Combinations of 2 groups, you divide it by probability.
Okay.
Okay. Question 3. How many possible arrangements, and so right there, the word arrangements clues you into the fact that it will be a permutation. Okay. How many possible arrangements are there of the letters in each of these words? Tourville, in, and abazaba. Ah, favorite candy. Okay. So let's do the abazaba. Abazaba. We have 1, 2, 3, 4, 5, 6, 7 factorial, and we're going to divide by, let's see, we have A, so there's 4 of them, and we have a B and a B, so 2 factorial. The common mistake is people say, well, there's 4 A's and there's 2 B's, so I'm going to divide by 6 factorial, and that's not right. 1 Z, don't have to do anything about it. All right, so that's what we would get. And lastly, question 4, how many different arrangements of the letters NSEW so this is a compass rose, north, south, and to the right is east and west. How many different arrangements of the letters, if we were to take them, would there be?
It's the circular one.
This is a circular permutation. Wonderful.
What's 4 minus 4 x?
4 minus 1 what?
6.
Factorial.
Factorial.
Good. 3 times 2 times 1 is 6. Okay. Questions? Combinations, permutations, fundamental counting principle. Yeah.